So let's talk about outer enums. Okay, this is very cool. I really want to make sure that you all walk away understanding what this is, and then we'll do hooks, and then we'll do coding. Okay, outer enums. In this presentation, you will learn a common pattern used throughout Frame, which abstracts many of the separate types into a single unified type that is used by the runtime. This is also called an aggregate type. Okay? What do we mean? So, as you've been learning in Frame with all the palette macros and all this kind of stuff, there's really 4 main enums which you will encounter through your Frame development. There's the call enum, the event enum, the error enum, and the origin enum. All of these enums have some representation within an individual palette, but also the final Frame runtime, the final composition of all palettes together should have some representation of this aggregate type. That's what I mean by aggregate, right? So you can have 4 palettes, each with their own calls, but at some point in the runtime, you need to be able to know what are all possible calls, right? So there could be some outer aggregation of these call types, of these error types, of these origin types, of these event types. Okay, and that's the problem we're going to solve here. And this is very much just trying to keep Rust type safe and working. It's just, I think this is actually a pattern that you would come to the conclusion to make as well if you were designing a system like this. Okay? So let's break it down without Substrate. This is my favorite thing to do in terms of learning Substrate is trying to do the same thing without Substrate, right? So let's break it down without Substrate. So if you have this these lectures, you can copy and paste this into a, I think you can even copy and paste this into what is it, Rust Playground, and it will run, right? But let's look. So first thing we have here are a few palettes, right? I create a module called balances. It has a enum call, which has some different calls with parameters inside of it, right, coming in. There's an enum error with the different errors that can happen. There's an enum event with the thing. Now, obviously, there's no logic here, but this is like the basis of the things that I want to show you the aggregate of, right? So you can see here there's a mod with all these different enums inside of it. By the way, the call enum, it starts as functions, but in terms of representing the dispatch logic, it dispatches to an index, right? So when we say the calls have an index, right, that's because an enum is being generated in the background. Does that make sense? So there's a function being called, but an enum is representation of like which function am I calling, right? Okay. So now we have a democracy palette. It also has some calls with the properties, or what the things that goes into the fields, the errors, the events, and these events have some fields. And we also have a staking palette with some calls, errors. And I want to add here that this staking palette, this is included with every palette, but I only wrote it once, so I can kind of minimize the duplicate code. But you can see, obviously, here, there's also logic that converts this error type in the palette to the dispatch error type for the module. Remember, we talked about that, right? So there's an outer error type that is this dispatch error. And so this is really what this looks like. So it goes from the conversion between error to dispatch error. It's putting it into the module variant and then using module error and then passing the index of the staking as the first index and the error as the second index. This is exactly what I taught you this morning, right? This is the code that basically is doing the same thing, okay? Again, without Substrate. This is Substrate without Substrate, or Frame without Frame. Okay, so we also need, for this to work, some primitives. So this is the same things that you saw today in SP primitives. There's a struct module error, right, which it contains 2 indexes telling you that thing. There's also a dispatch error, which is the enum, and it has a variant bad origin and a variant module with the module error, right? This is like, we exactly saw these things. There's more, but this is exactly those same things, right? And then we finally have our runtime, right? Our main runtime, which aggregates all of these paths together, uses the primitives and actually generates the final runtime state. What does that look like? We'll start. Remember the construct runtime? It has the index of all the different palettes. This is what that kind of, I mean, it's not exactly right, but that's basically what's happening. In the background, the construct runtime is collecting all the palettes and assigning them an index in an enum variant, right? So balances is 0, democracy is 1, staking is 2, and this index is obviously used to populate the fields in these errors and stuff, right? So error from palette 1, what is that? That's democracy, right? And then we also have runtime call. So we had already defined above, each of these different palettes have their own call enum, right? And so when we aggregate them together in the runtime, we create a runtime call, which has a variant for each palette, and inside that variant is the content of their calls. So you can see here I've made now one structure which has every single call in the runtime, right? There's a way to navigate to it. If I want to call transfer, I do runtime call, colon, balances call, colon, transfer. Or I guess it's balances call, parentheses, balances call, yeah, you'll see. I show the example, okay? But you can see I've aggregated all of the calls together into one object. Similarly, what am I doing here? Event. I've aggregated all of the events together in one palette. And notice staking didn't have any events, so it's not in the enum. So actually indexing here might be a little bit weird. I think Substrate does this too. So indexing might look a little bit weird. Like it might skip over a palette if there isn't an aggregate there. But that's fine. In this context, the runtime event is again the aggregate of the separate events put together, right, and indexed. So I'm able to reference every single possible thing. And there is some code in here you can see I've written, which allows you to convert between a specific palette event and the runtime event, right? And I'm trying to remember. I think if you remember inside of the event talk, the runtime event, it had those trait bounds. It was like the from and into. You remember what I'm talking about? If not, let's maybe just look at it real quick. So every single palette, if we go into the palette, we go into the config trait. Every runtime event is required to implement from event and also is type runtime event. Okay, this is the requirements. And what I'm saying is that when we generate the runtime code, the macros are doing this for you. They're ensuring that all of your event types can actually convert into the event that we need, right? So that trait bound is actually being satisfied. So again, imagine this for all the possible types above. So for every possible event type, we are able to convert it, try from into runtime event. Some logic like this, okay? Is that it? Was that all of it? Okay, and then what the primitives? Oh, so yeah, so next. So that explains at a high level how we're taking all these individual enums from different palettes and in the runtime aggregating them together. So let's take a look at what these things look like, right? And how they're encoded. So what am I looking at here? So in this first line, I'm looking at the democracy call. So this is how a call in the palette is encoded, right? So let's go back to this code here. Inside of democracy, there is a call proposed, the first index, and then it includes some hash, right? So if we go over here, to serialize what that would look like in the context of the palette, it's going to be variant 0, and then the hash, which is all 7s in this case, right? That's what the data inside of the proposal hash is. But if we were to encode this from the runtime context, right, then we also have to include the palette index, and then the call, and then the hash. So we add one extra index here to tell me which palette this is the call for, right? If we look at the error for staking within the context of a palette, it's just variant 2, right? But in the context of, can I scroll up a little bit? No. In the context of the runtime error, remember, it needs to match into the dispatch error, right? So it'll be module error, palette 2, error variant 2, right? And then same with the events. The event is the same thing, right? The runtime event, the balance of the event, you'll get more indexing. So basically, we're serializing things and we're adding more context to be able to identify which palette this stuff is for. You have a question? Can we get a mic over here? Where are the box? Yeah. Thank you.
Thank you, Marcos. So, And yeah, we are aggregating all the calls, all the palettes, runtime, errors, and events, right?
We're aggregating them in the runtime.
In the runtime, exactly. So you say, okay, with the palette call, you said zero. It represents the first index.
Yes. So this is the call on propose, and propose is the first call.
Oh, okay.
In here. It's the very first variant. So that this indexing is telling me I'm calling propose.
Okay, so the okay.
This tells me I call propose. This tells me the information inside the palette. This one tells me call palette index 1, call index 0 with this data.
Okay, and the error just only one data. It doesn't really specify the index of the error, because the error mostly are enums.
Well, this is the index of the error. This last one.
Oh no, the
this one
palette error.
Yeah. So there's 3 bytes here, right? Let's go back to my thing.
Yeah.
The first byte tells me if it's which one of these it is.
Yes.
So it's 1, so it's module error.
Yes.
And then the other 2 bytes tell me palette and error.
Okay, sure. But then can you go back? There is one which has only one element. Yes,
this palette error.
Yeah.
Right. In the context of a palette, there's only an enum. So in the context of this, let's say this palette, there's this is 0, 1, 2. So it's only that.
So it says the number of errors in the palette.
Not number of errors, the index of which error it is.
Oh, the index. Okay.
Right. So
okay,
let's go back to here. And again, what am I encoding? In palette error, which one's palette error? Palette error here, I'm encoding the staking error. I'm encoding the error already bonded.
Oh, okay, so it's the only that.
So I need to know which one it is. It's the index in the enum of already bonded.
So the context is only from the staking palette, not from the runtime.
Exactly. That's why it's staking error. But then in here I do staking error into dispatch error. This is the runtime.
Runtime. So now everything.
Yeah. Well, let's keep going. And now let's look at the real runtime. So this was all using my code. Again, you can copy and paste it. You can run it. You can see the exact same output. But I actually made a test that you can copy and paste into no template runtime librs, which does all of the same things. Right? Literally calls the palettes, calls the call. You see now I have the runtime as a generic, all of these things. And so let's see what the output of this is. It's exactly the same. This is the real runtime output. Palette call is 0, 3, 1. The runtime call tells me the palette index and then has all the same data, right? The palette error is just 2. The runtime error is a little bit more. It's a module error of module 5, error index 2, and then the unused bytes. Remember, the error had more bytes, right? Palette event, it was just all 2s. Runtime event, first the palette index, then the all 2s, right? So again, it's not really rocket science. Just imagine in terms of encoding, we're using enums to basically take many different errors and be able to identify which error is for which, right? It has a little bit of extra bytes to tell me it's this palette, this error, this whatever, right? And so from the context of the runtime, I'm able to distinguish all of the different things, right? There is no ambiguity into which call is going to which palette, is going to which what, right? Everything is just like our frameless mock, but the types are just more complex. Using outer enums. So the path for using outer enums can be a little bit confusing, right? The types which compose the outer enum come from the palettes. They are aggregated back in the runtime, and they can be passed back to the palette. That's some of the stuff I've been trying to show you, and it's kind of like dancing around. Let me say this again. There's a type in the palette, right? Let's say there's an error in the palette, an error enum. Somewhere, let me say event, because that's easier. There's an event enum in the palette, right? That palette only knows about its events. Somewhere in the runtime, we aggregate all of the events. So now there's events from all the palettes. But if you remember, we've already actually included the runtime event back into the individual palette. That's what's happening here. Let's go back to here real quick. This runtime event is the type including all events. All events of the runtime. But it's from the context of a palette which has no idea what other palettes are in this runtime. Isn't this fucking wild? But Rust can actually compile this and solve it in a type-safe way, right? And I'm able to access my events within the context of this runtime event because I've implemented this trait. I know there's a way for my event to get to the runtime event. I don't have access to any other events. I can't do a balance event. I can't do a staking event, but I can do my events. And I can deal with a type that has all possible events in it. This is really like, this is like, kung fu magic. It's quite amazing here. We're able to pass things around. So let's see what I said. Yeah.
But in this example, you said that I cannot send, like if I'm in a palette X and I want to send an event for palette Y, with this design I can, right?
You cannot. Because
Why?
your palette, unless it's tightly coupled to palette Y, you can't do it, right? Because your palette is a crate that has no context of other crates.
Yeah.
Okay, let's finish this and then we'll figure it out, okay? So, if we actually go back to frame system, we will see all of these aggregated types. In frame system config, we define a type, runtime origin. That is the accumulation of all origins. Runtime call, that is the accumulation of all calls. Runtime event, that's the accumulation of all events. These are defined associated types in the frame system config. Okay? And then again, we're going back to palette event. This exact same thing. I'm re-emphasize it again. This is why we need to add a runtime event associated type into our individual palettes, because we need to know. So we know in frame system there is a runtime event. This type is what's used to emit events and stored into the storage. We need to know that our event is part of that type so that we can send it to frame system, right? If we didn't know that this event was part of that frame system type, we couldn't, of course, send it for them to store. But because we know using this trait, or maybe that trait, let me think, which trait? Because we know with this trait that our event can be turned into runtime event, we can then send it to frame system and they can store a runtime event. That question? Oh, that's it? Okay. This is where your heads melt, and this is where it's very cool. Now, let's go back to the conversations we were having about this aggregate, right? So let's go back exactly to what we did here. So sorry, let's start with this. Does it kind of make sense, this idea of aggregating the types? How it's useful for the pattern of palettes, where we have these individual modular systems that all work together. Does that make sense? Okay? So we showed you the default, the most commonly used aggregated types, the origin, the call, the error, the event. And you can imagine that our macros are able to generate this for you because we have a call error, or a call macro. We have an error macro. We have an event macro. We have an origin macro too. I showed you that in the other slides, right? So all of these macros are doing the tricks of identifying this is the thing that I'm going to aggregate together, right? Now, what we saw today, and actually it was honestly new to me as well, was this aggregate thing. Which project was it in? Multisig? Multisig, thank you. This aggregate thing. Palette aggregate. Yeah, this composite enum. I believe, so this is new code. This is new for me. But what they've done here basically is they've extrapolated this. Why can't you just do this for any enum that you want in your world? If you're making 20 palettes, you can make your own aggregate enum with your own variant. And what magically is happening here is that we've defined an enum with the name hold reason. And this macro is telling the construct runtime, generate a runtime hold reason with all the aggregate of all the palettes that have the same enum. So if I make a second palette and I also put hold reason, my aggregate enum will contain both. So this is like basically like an infinite extension of this idea. So you can imagine you're designing a system of palettes which all kind of work together, And you might want to access your own aggregate enum. This is a general way to do it, and we've done it with some macro magic. And so let's go back to what we exactly implemented. We have here inside of this palette a hold reason, a single hold reason, right? Now we know what will be generated in the runtime is a runtime hold reason with aggregate of many. There could be many different options of hold reason, right? What we've done now is pass back into our palette the runtime hold reason type, and we've made the requirement that our hold reason has to be part of it, right? If our hold reason isn't part of it, then nothing will work. Everything will break. We've made the requirement our hold reason is part of the runtime hold reason. And this is guaranteed for us thanks to this macro. It's doing it for us. It's automatically doing it for us. One last time. And finally, when we define the native balance palette and we are using holds, we define concretely the reason is the aggregate runtime hold reason. It's not just our hold reasons, it's the aggregate hold reason, right? So this is kind of, again, like going back and forth, and we're doing all the generic type magic. At no point here do we know what the runtime hold reason is. We have no concept of all the other reasons. All we know is that our reasons are part of the aggregate. And Rust, at compile time, can figure out that all of this works. Type safe. It's not guessing. It's not waiting for you to run into some error like JavaScript or whatever. At compile time, it knows that all of the rules have been satisfied. Okay, now you can ask a question. Yeah, you need the mic.
You answered.
Great. I think this is very, very cool. This is why I have a lecture on, that's why if you look about today's presentations, I'm showing you all these different things. I'm hinting at this, aggregation or whatever. This is not Frame at all. This is just Rust. Rust is able to do things like this. It has the power.
Yeah, one thing is in the self runtime hold reason, right? Okay, we're getting the aggregation, but okay, so that macro compose enum, right? Then compose enum, the macro which will compose the enum. Is the construct okay, putting that also. Oh, okay, so you can see the runtime compose, but then it will be generated.
Let's do something cool. I have a cool idea. Let's do cargo expand p node template runtime.
Yeah.
Oh, let's output it to out.rs. Okay, let's see how long it takes. But what I expect to do is I'm gonna generate all the code for the runtime, and I'm gonna be able to find all of these aggregates. And I should find somewhere in there runtime hold reasons, and I should see my hold reasons, and I bet you there's probably hold reasons from the balances palette in there too or something. But I'm gonna find it in there. And maybe we could just generate another random aggregate, and we could just see it be generated in runtime. That would be cool, right? Okay, it's thinking. Any other questions while my computer thinks? So again, this lecture is not something, it's not, you don't get tested on this information. But I think that Substrate makes a hell of a lot more sense when you understand what's going on in the background, right? This is that stuff. So, I mean, clearly, as easy as a framework as we want it to be, we want it to be flexible and safe as well. Some of these things are the complexities of our framework. But I think once you understand it, it makes a lot of sense why we did it and how it works and what it provides to you, the flexibility and accessibility. And I want to remember, go back all the way. So let's go to the intro of Frame. Let's go here. Remember, when we design these frameworks, we have goals in mind, right? Maximum flexibility and compatibility, maximum modularity. This is the result of those decisions. There is another framework which exists, which is maximally simple, maximally opinionated, maximally whatever. That is not what we built, okay? But you gain a lot from this, right? With Frame, you're not creating a bunch of the same blockchain. You're creating an ecosystem of application-specific blockchains with their own design, with their own, meaning and feeling, right? Okay. So let's see how my computer is doing. Yes. Can we move a mic to the front?
I don't want to get too deep into a debate, but I think there are drawbacks for this, and one of the drawbacks would be that it's less accessible to a lot of developers. So maybe there could be a chance to have another framework that uses this as an underlying infrastructure, but create like more easy to use, at least to create stuff on Polkadot that is not that complicated, because
Yeah.
I think that there's a barrier, a lot of barriers. We are here like for 1 month to learn all of this, and I imagine that that millions of developers that won't be able to work with that.
It's not even an argument. I 100% agree with you. So this November, I made a post on the forum, 9 ideas for the decentralized future of Polkadot. And one of my ideas is an alternative to Frame. Right? I say exactly here, it's obvious to someone who's an expert in Frame how flexible and modular it is and how it can really be used to develop fully customizable systems. However, to many entering the system, Frame itself can be quite complex to use, especially to use correctly and safely. I argue of these 3 options, right? I think, did Keon show you this? Right? Like in between, this, of the 3 options, no one is really building or modifying core. No one is working here, and no one is working here either. Everyone is working here. And so we have presented 3 options, but we've only given you one option that is really usable. And so I'm of the opinion that we need a more framework which is more simple, stupid, easy, safe, redundant, satisfying, and so on. So anyway, you can read this. I agree with you. But how can I say this? Frame is the right tool for building Polkadot. And our mindset, in terms of what Parity is building and stuff like that, is to build Polkadot. These cohorts, why do you think that Parity Polkadot invests in bringing experts out here, helping you all? This is the task ahead for you all, right? Like, if you are the right person, maybe you are. Let's do it. Let us help you, right? But it's not, this stupid simple framework is not going to help make Polkadot better or Polkadot relay chain better. Does that make sense?
Maybe we'll make Polkadot more adopted, because
Yeah, but
it needs like adoption, and adoption
I
needs
agree.
a lot of applications and easy stuff for people to get in. And
I think this. If I had to figure out why I'm here on this stage teaching you all, it's to enable this. This is my impact on that. Okay? Cool. Okay, so let's go back to this thing. So here is the macro-generated code from the runtime. Now, I think at the beginning, I had to skip a bunch of code. I think this is the WASM. The WASM is built into the runtime in here, so it's embedded, so there's a huge amount of garbage text. But you saw, wherever I just stopped, that was actually perfect. So let me go back to it. You see all of this code being generated, but there was this thing called Enum runtime call. Bam. Look at this. System, index 0, timestamp, index 1, grandpa. So you have an enum of these things, and this system variant, it has inside of it, some with all these words here, callable call for system runtime, callable call for timestamp runtime. Like you can see, basically that's what's happening, right? We can go to enum runtime event. It's exactly what I showed you here, right? There's a runtime event, variant 1 system. Inside of it is the type frame system event. Variant 2 grandpa, inside of it is the variant palette grandpa event. It is exactly, this is what's happening, this is what the code being generated. And then runtime hold reason, bam. This code is exactly the code I wrote. The multi-sig palette was going to hold reason. And I guess there's no other palettes doing it. So again, we created this macro, which just, I guess, magically, I don't even know how this works, to be honest, but magically is able to aggregate custom enums that you want. So if you're building 4 or 5 palettes and you want to access this, you now have a way to do it. You have to make sure that the exact text is the same. So this is the runtime literally presenting an aggregate view of your whole blockchain. And so I think the last thing I want to look at real quick is if you go into the runtime, we actually use this aggregate stuff a lot. So when you go in here, and I do look at runtime event, there is a type runtime event in frame system, which is being assigned to this runtime event, which is the actual concrete type. If you look in this code base, it doesn't, I guess runtime events everywhere, so I should do something easier. Runtime error, runtime call, okay? If I look, there's no actual definition of the runtime call, right? It's just people using it. That's because the macros are generating it. It doesn't exist in this code because it's being generated for you, right? But in the background, you can know in your head the runtime call is an enum with the variants of the palettes, with the calls in it. That is what's actually existing. And if you ever had doubt, you can generate the code and you can see that for yourself directly that it is existing at some point, right? It is being generated at some point. But this is also, again, this is the fine line between macro magic and making things developer friendly. Like, would you rather write all this code yourself every time? No. Do some developers bang their head because they're like, where is this type coming from? Yes. There's a combination of education and, I don't know, maybe just blindly accepting that things work. That's worked for me so far, so yeah. Okay, any questions about this aggregate type? Did I answer some of the curiosities people had around this aggregate stuff? Yeah, because the questions were coming. Yeah, please, the mic.
Yeah, hello. Yeah, I just wanna touch on Gabe's issue because it was like a lot of debates in the discussion. And one thing is, can you check in the conversion of runtime origin to it is runtime origin to raw origin? Yeah, yeah, from runtime origin to for results raw origin, something like that. So up, go like no scroll no up like yeah that one. Yes. So
Make it bigger, I guess. Impl from runtime origin for results, raw origin. From val runtime origin self val caller system. And so what's
so
the
issue
debate
was
here?
that most palettes assume
Most palettes assume raw origin signed will be the origin making calls by using ensure signed. My custom origin is multisig ID because then I can write calls that should only be called by multisig. But I also want the multisig to call normal palettes and is derived account ID. Problem is that the construct runtime macro auto generates this conversion. Yeah, so okay, so he's doing hardcore stuff. So first, Gabe clearly understands what's going on behind the scenes because he wants to override the default generation.
Yeah, so my
Okay.
question was what was the limitation actually? The limitation because some
So is he saying that he can't do this?
is so some are arguing like he can do that without modifying core construct runtime
Right,
macro.
because what's going to happen is this. The construct runtime is going to generate this code no matter what,
Yes.
and then he wants to not generate it, and he wants to write it himself. So I think that the answer to this problem is there's a feature which doesn't exist, which he should add,
Yeah.
which is that he should go into the macro code, and he should add some kind of feature flag or some kind of way to signal to the runtime, don't generate this, I'll generate it.
Yeah.
And that's why not. I mean, it's like, you know, like every single feature. Again, I think I said this also inside a frame. Just because something doesn't exist doesn't mean that it can't exist.
Yeah.
So every single one of these features in frame, where we have even this aggregate composite enum, was that we were solving some problem. It takes code to write it. So I absolutely believe that with a little bit of macro code, that we could change construct runtime to support not generating the enum or the event thing and then doing it ourselves. Yeah, I believe with a little bit of macro code, we could support us telling the macros, don't generate some code for me, I'll write it myself. But the problem right now is I think no one has asked for this feature, and therefore it generates code and we generate code, and that conflicts.
So we can put like a conditional generation in the macro.
Yeah, why not? I mean,
maybe proposing some RFC in the.
It maybe doesn't need to be RFC. I mean, you could talk to Keon. Keon, you know, is the lead of the frame team. But you could imagine, for example, in construct runtime, that for palette multisig, that's his palette, whatever he wants, right? And then he doesn't want to add the origin, so it could be something like, I mean, this would be terrible syntax, but it would be like, you know, here like frame skip origin or something like that, right?
Yeah.
Like you can imagine, like you just tell the macro, I don't want you to generate this code. It's like what again, you're all programmers. Whatever you can think of, if you can design a program that can do it, it will do it. So I mean, this is 100% possible. It just requires someone to write the specification, to write the code, test it, implement it. And by the way, this kind of stuff is backwards compatible, right?
Yeah.
If you don't use it, it doesn't bother you. So why not? And again, the other thing is that macro generation all happens in compile time. There's zero overhead to this stuff, right? This is all compile time happening. So you can add as many features like this as you want, and all of your blockchains run exactly the same. Fast and easy, right? Okay, so yeah, I mean, tell Gabe this is the answer. Okay, any other questions about the aggregate enum? I hope it's obvious why I'm a little bit excited about this presentation, but also why I include it, right? It's not Frame, but this is a very important insight into Frame and how things work.